Start recording. Okay. Hello everyone. I'm Nisha Shingan. I'm your instructor for this stack. So I'm very excited to start this journey with all of you. And welcome to Machine Learning Stack 2. Welcome to Week 5, Lecture 1, Data Science in Python and Machine Learning Coding Dojo. Announcements. The new stack is open for you. Make sure to go to the learning platform and start in the new stack. If you haven't started on this week's lessons and assignments, start those as soon as possible. And your all assignments for this week is due by Friday, 9 a.m. PST. And the machine learning calendar has been posted here. You can click on this. You can go through this calendar and you will also take a look at what you need to read before coming to the next lesson. Okay, so these topics are mentioned there, and we have a break week, Thanksgiving Day, that is from over year 21 to 24. Okay, make sure to sign up for group code reviews again. This is highly recommended to book a group code review or 101. If you have any confusion, please feel free to post questions on Discord as well. TAs are available and I'm also available. Okay. And these are an important part of your learning. So you are paying for them. So try to group a code reviews as much as you can. It will help you to clear about the concepts as well and coding skills as well, and how you can be a more and more better in EDA, machine learning, prediction, and everything. And remember to check your feedback document on regular basis. This is very important. Okay. Your assignments due this week by Friday morning. The 3 assignments are due. That is your abalone pre-processing exercise, pipelines activity, and project 1 part 5. These 3 assignments are pending or due by Friday 9 a.m. PST. And this is a very important note for your project 1 part 5. Do not use your previous version of the notebook. What you need to do, make a new notebook for this assignment, load the data set again, and then you start doing the pre-processing. Okay. Do not use your previous version of the project. Why I am saying this, you will come to know very soon. Okay. But you need to follow these steps. This is very important. Okay. Any questions about the announcements and your assignments?
So for week 3, we'll still have work. It's just we won't have any class.
Right? No assignments are due.
Okay, but there is still like material to read and
you
all
still
that.
Have access to all 4 weeks of the stack.
Okay.
So you, if you want to get started on week 3, which will take up the following week, you can.
Okay. For sure.
The project 1, you mean that we're gonna do it in GitHub?
Yes.
Okay.
But you need to make a new notebook for this. Load the data set again. Don't use the previous version. Okay.
Yeah, sure. Thank you.
Okay, thank you. Okay. So which topics you need to cover before next live class? This is your column transformer and simple imputer. If you want to look at the topics, you can click on this. This is again the same. And you can have a look here what you need to read before your next class. Okay. So this will help you to understand the concept as well. And it will also help you to asking the more and more questions as well. Okay. And so over today's agenda, today we will you are going to start a new journey that is totally different from the fundamentals which you are going to start today. Okay, and this is where you all will enjoy this journey. Okay, you may find little bit difficult in start, but don't worry about that. Okay, slowly you will start learning this, and you definitely you will do good all in this. So in this we will cover today, explain what is machine learning and what it does, describe the different major types of the machine learning, define model validation, and explain how we know if a model is valid and work in the real world. What are the features and targets? And split the data into training and testing set. Don't worry about these words. Okay, you will definitely understand when you will go through today's lesson. Okay? So before moving ahead to the directly jumping into the definition of the machine learning, I would like you all of you to introduce with the applications which we use in real time. So you will get an idea where is the machine learning used. Then we will come on to the definition of the machine learning. So now if you look at this, your diagram, right? In this, you can see these all are the applications of the machine learning. So we will start with the first one, that is your automatic language translation. So this is the very popular application of your machine learning. Maybe you have seen on the Google, whenever you are trying to convert any language into other, it is automatically transferred. You only need to click that, or sometime it asks you to convert the language whenever you are opening the page. What is the reason behind that? What is happening in the background of that? So this is a model of machine learning. So this is everything is done by your machine learning. You are the one who are going to prepare these kind of the machines in the future. Okay. So medical diagnosis, this is another very good and popular example. If you go to the hospitals today, you know how you come to know about the rating of the hospitals, how many successful operations are done over there. You will see a lot of things, and some tests are going on, how the machine is helping you predict. Like for example, if I give an example of a hair disease, if we want to predict like whether the patient have this disease or not, this is predicted by machine. So behind this, again, there is a machine learning. So we have, like the people have made, the great data scientists have made these machines. Okay. So machine learning is there. Stock market trading. When you open the site, how you will come to know today's the market is going to be down, it is going to be up, right? Again, there is a machine learning. So if we look at these three examples, you can see machine learning is everywhere in every domain now. Online fraud detection. This is again, we take an example of banks, credit card fraud, right? How the people will come, how we will come to know, how the bank will come to know this is a fraud call or not, right? And virtual personal assistant, this is very popular. Either you go to the shopping website or you go to any website, you will see instead of talking to the human first, you will talk to the virtual assistant. When you say hi, they will ask you very general questions, right? They will ask you, they will say you, I'm a boot, I'm a this. So do you want to talk to the customer support or not? I can help you. So this is all virtual personal assistant. This is helping the people to save a time. They can reduce the manpower. They don't need to pay extra. They can use the machines to talk to the people, right? Email spam and malware. If we want to know how your emails are filtered on the Google, Gmail, or any other domain server, right? Self-driving car, again, this is a part of your machine learning. How the self-driving car works, you only need to enter the address and the car will drive itself. It will face any obstacle on the route. It will overcome to that. This is again a machine learning, right? It is trained in a way like that it can handle these kind of things. Product recommendation. If you go to any website, when you are doing the online shopping, you may notice like there, if you buy a one t-shirt over there, like red color, right? It will start showing you the another thing matching with that. It may be trouser, it may be another t-shirt, anything, right? It start come automatically. Even next day, if you open the page, it will start showing you that kind of ads, right? Because you have visited that page. So this means machine is working based on your interest, right? If you look at the Netflix, you are watching the movies, it will start showing you the movies according to your taste at the bottom, right? And then you have a traffic prediction. Traffic prediction means like, again, there is a machine learning. How we will come to know online there is a more traffic or there is a less traffic. There is a something happened in the middle. You can take this route, right? So this is again machine learning. Speech recognition. If we talk about the speech recognition, sometime we want to recognize, is a kid is speaking, girl, boy, who is speaking, right? So this is again another example. Image recognition, very popular example again. If you Google something, even if you upload the pictures on any social media, how it will be sometimes categorized itself. It make its own album customized, right? According to the pictures. So this means this is recognized by machine, right? So these are the very, very popular and common examples of the machine learning. I'm not saying these are the only, there are a lot of more examples in this field, but this is the most common applications which is used in real life. So you may have a little bit idea what is the importance of machine learning. You can see machine learning is everywhere, in every domain. Now it depends upon your interest in which domain you want to work, right? So you have a lot of opportunities. Any questions about applications of machine learning? Okay, take your time. If something come up in your mind, please feel free to ask. Okay. Look at this picture. So we will talk about now definition of the machine learning. So what is happening here? Now, this is a human, right? We are all human. We know, we learn from our experience. If I did I have experience in one field, I will learn from this. Then I will take a decision in future. This is our nature, right? But what the machine is saying, machine is very smart, right? Machine is saying, if you are learning from your experience, I can learn from the data, right? So this means your machine is learning from the past data, right? Which is stored on the server. We take the data, we do some analysis, which you are going to learn in this stack. We do some predictions. We look at the patterns, different. If you have a 5 years data, 2 years data, 10 years data, you will look into the different patterns of the years, right? By looking at the data, and then you will start doing the analysis. Then you will make a machine, you will make a model, right? Based on different patterns. So this is a machine. So machine is also very smart. So now what is the definition of the machine learning? So your machine learning is an application of your artificial intelligence, okay? That provides the system ability to automatically learn and improve from the experience without explicitly programmed. So what does it mean? Explicitly programmed. Any guesses? Anyone? Okay.
So
Well, I guess you're not writing a function, right? Like it will be able to perform X, Y, or Z without you necessarily needing to write some sort of function or like specific command.
Yes, you like answer. Great answer, right?
Or alternately, like you tell it what you want as the result, but you don't tell it how to get there, and it figures that out on its own how to get there.
Okay, great. Anyone else? Okay, yeah, All are doing great. So this means explicitly means you are not going to instruct your machine every time, right? You are going to train it one time and you are going to use it for lifetime. If something changes come up, then you will upgrade your machine, but you don't need to instruct it every time. Okay, it will work itself. That's why we say this word, explicitly programmed. Okay, great. Any questions still so far about applications, about the definition? Okay, take your time. So now, till so far, we have talked about the applications. That is the very popular, most common used in real life. And then we talked about the definition of the machine learning. Now we will come on to the types of machine learning. How many types of the machine learning we have? So we have two types of machine learning. Okay. In this, in this your certification, we although you have a third type of machine learning as well, but you are going to cover up supervised, unsupervised in this. This is a widely used your type of machine learning. So now look at this. So first of all, we will talk about supervised. If you look at the name itself, supervised means something which is under supervision, right? So if we look at this, think like this way, we already know which is happening under someone's supervision. So we will call it supervised. So how? In this, you already know the answer, right? Look at this picture. This is the instructor. This is, we can take over examples. These all are you and this is me, right? So in this, what we are saying, students are saying, train me, right? So what I am doing, I am telling you about the content. I am giving you the live classes, lessons, assignments. So I am going to train you in machine learning, right? If I am giving you the content, questions, I'm also giving you the answers as well. I'm telling you the answers as well. If this is the question, this is the answer. This is the question, this is the answer. So you are learning from you are learning in supervised this way, right? You know everything in this case. So this is the supervised machine learning, okay? So I am just explaining you as a layman right now. So we will talk about technically as well in upcoming slide. But in this case, in supervised, you know the answer. If I am connected again with us as examples, if I'm saying you, what is a machine learning? If I asked you this question, I'm telling you the answer as well, right? So you are learning everything under my supervision. Okay, so this is called supervised machine learning. But if we talk about the unsupervised, right? You all are saying, Nija, we are self-sufficient in learning. We can train ourselves, right? We don't need every time supervision. Okay. So I'm just giving you the content. I'm asking you the question, giving you the content, but I'm not telling you the answer. I'm only giving you the content. So you will try to learn from the content. You will try to find out the answer from the content, right? So this is the big difference between supervised and unsupervised. Okay. How it is like technically different, technical definition, we will see in upcoming slide. If anybody have any confusion, please ask in the definition. Anyone? Okay, take your time. Your machine learning further divided into more parts. When we are talking about the supervised, it is further divided into regression and classification. Okay. Regression is a one type of your algorithm. Classification is another. Okay. And when we look at further unsupervised, Unsupervised is further divided into clustering and dimensionality reduction. Okay. But in this stack, you are going to cover up this portion. Okay. You are going to learn this. This is you are going to cover up in next stack. Okay. We are going to do this thing. So now it's a poll time. Okay. So we will do one poll before moving ahead. So there is a one question on your screen. What is a machine learning? Nice. Good, 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 good. One more response is left. Good. Very good. Okay. So what is a machine learning? The answer to this question is all of the above. Okay. This is the correct answer. Because you are using machine learning to extract the patterns from the raw data. Right? This is the kind of tool which you are going to use for your raw data. And it's also application of your artificial intelligence, which we have done in the previous slide. Okay. But it's very good, very great response. Now we will move ahead. Now, till so far, we have learned about the applications of the machine learning. What is a machine learning? Types of a machine learning, right? As a layman, right? And then now we will talk about the life cycle of machine learning. Okay. Now look at this diagram. So this circle contains the steps of your machine learning life cycle. So what is that? Machine learning's life cycle means the steps which you are going to take to make a model. Which steps you are going to follow one by one to make a good machine learning model. Okay. The very first step is this one, data gathering, right? So if you want to do something in machine learning, which is the first requirement? Data, right? If you have a data, then only you can move ahead. So this is the first step, data gathering. But here, when you have a data, you should know what you want to do with this one, right? If you have a data set, then you should need to decide what I want to do with this data set, right? If I'm giving you one data set of a patient's, right? And I want you to know, like I'm saying, can you predict whether this patient have this disease or not? So this means I'm giving you are gathering the data from me, and you also have one goal, what you want to do with this data set, right? So this is a very, very important step. Okay. Never ever move ahead if you are not clear with your goal. Okay. If this step is going to be wrong, your whole process is going to be wrong. Okay. So never ever rush here. Take your time, even if it takes you 1 hour, do that. But never ever predict or set your goal wrong. Okay, this is very important. And after that, your second step is data preparation. You gather the data, right? You set the goal. Now what you want to do with the data, right? Maybe you got a data from different in Excel sheets. Maybe you get the data from different location. It is not mandatory you will get a data in one sheet, right? You may get it from different platforms. Then what you will do, you will start loading the data. You will look into the information of the data. Okay. And then you will see how many columns, how many records, how many features you have in the data and what type of data you have. So this is called data preparation. And then you come up with the data wrangling. In data wrangling, what you do here, you will try to do something with the data. You will do some manipulation here. Okay. If you have something missing in the data, you will take action. If there is something duplicate, you will take action. If you want to separate something, you will again take action. And then your fourth step is data analysis. So here you will decide everything, what you want to do with your data, what type of data you have, what action you want to take, right? So you will decide everything here. You will see this practically when we will do the code along. Okay. And then model training. This is the very important step again. Every student want to reach here very soon. Okay. Once you get the data, you will do data preparation, this, and you just want to fit the model very quickly. Okay. I would say spend your time from here to here as much as you can. Okay. More than 90% data scientists spend time on these steps because this is the only thing which is most important. If this thing is going to be wrong, your everything is going to be wrong. Okay. So this is very important. So model training is nothing. You will set a model. I want to use this model and you will fit onto the data when it is prepared for modeling. Okay. And then you have a test. This is again important step. Now your model is trained. You already trained your model. You have given the instruction, right? Now you want to test it with the new data. That is called model testing. Once your model is ready, you need to evaluate it. Is it working good or not with the new data? This is most important step. Okay. And then deployment. Once you are sure 99% even more than that, then only think about the deployment. This is the most expensive step. Okay. Like if you want to go back here, this is very tough. Take this step only when you are sure with the new data. If your model is giving you the more than 95% accuracy, then only think about it. Okay. So this is the very important steps. This is machine learning life cycle. This is giving you the basic idea how you will start your journey in machine learning if you get a data. Any questions about the machine learning life cycle? Okay, I will ask one question. What is data wrangling? Anyone?
Cleaning the data.
Yes. Anyone else?
Kind of setting up the data the way you want it to. So like, if like standardizing it so that if nothing is overweight than the other. Yeah.
Okay, good answer.
Any examples from core project 1?
Changing like integers to I forget what it's called. Sorry, that's the best I can say. Converting.
Like finding all the null values and getting rid of them and finding when there's like objects that are the wrong types. So like low fat versus fat all in caps or stuff like that, that stuff is all data wrangling.
Absolutely.
And then I think it's like it's like tier 1 location, tier 2, tier 3, changing that to tier 1 equals 1, tier 2 equals 2, right? So that because computers don't understand words, they understand numbers, right? So converting the words into numbers.
Getting rid of endless decimal points too. Just cutting down numbers from like 8 decimal points to like 2. So they're a little bit more manageable.
Sure.
Okay, all are doing good. Great answer. Okay, so till so far we are done the topics. Now we will jump on to supervised machine learning. As I told you, we will talk about it technically as well. So now look at this example. So what is a supervised learning? As we have discussed, which is under supervision, right? So it has a target variable, right? And which is target variable is learned from the pattern, right? And then it decide if this is the pattern, this is the answer. If this is not the pattern, this is not the correct answer. So this is the way how your supervised learning work. So it is looking at the pattern, then the answer, then it is learning from this. You know the answer. And what is the answer? Those answers we call that target. Okay. If you look at these, this is on the right side the table. You have a 2 columns. Here is a 2 records, 2 rows. This is number of advertisement and total number of sales. This is called independent features. Okay. And this is dependent feature. We denote it the independent feature with the variable X and dependent feature with the Y. We also call it target variable. Okay. If you heard the word about dependent and target, they both are same. Okay. So this is, in this case, I know if there is a 5 number of advertisement are done by the company, they can make $100 on the total sales, right? If they are doing the 10 number of advertisement, they are going to make a $200. So I know the answer. I know the pattern. I know the answer, right? So this is called your supervised machine learning. Okay. Any questions about the definition of this?
Like it's bad pattern, yeah?
Sorry?
It's pattern.
Yes, this is your pattern, this one.
Oh, okay.
Okay. And we also call it independent feature and X features. We denote it with the X. Okay. Okay. Now it's a poll time. So what is a dependent variable? Two more responses are left. Okay. So what is a dependent variable? The value we want to predict. I got a 9 votes to this. The value we used to predict with, I got a 6. So what does it mean? The value we want to predict. Yes, Navnoor, you want to say something?
Well, I guess that's the value we want. That's the answer we want, right? The
Yes.
value we want to predict,
Yes.
yeah.
And the value we used to predict with. Can anybody explain this? If this is a correct answer, why?
Yes, X is the value we use to predict with, and Y is the value we want to predict.
Yes. Okay. So the answer for this question is the value we want to predict. Okay. This is your Y target, right? The value we used to predict with, that is your X feature, independent. Okay. Yeah, so we will move to the next poll. What is an independent variable? Good, 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 good. I got a 5 responses for the first answer. The values that interfere in the value we want to predict. And 8, none of the above. The first answer is correct, right? The values which interfere in the value which we want to predict, because those values are helping you to predict the target. Okay, these are X features and we will call it independent features. Okay. If there is any confusion in independent and dependent feature, I will repeat at the end of the lesson. Okay. Supervised learning regression. So now we know the definition of the supervised machine learning. The supervised is again divided into 2 parts. That is your regression and classification. If I'm talking about the regression, when your goal is to predict the continuous value, it can be integer, it can be float. When your target is, again, I will repeat, if it is in continuous form, it can be integer, it can be float, any real number. That is known as regression problem. Okay. So your model prediction can be any real number. Okay. If I give you one example, can anybody tell me, is this what I am telling you? What is the target in that and what it can contain? If I want to predict, if I draw here one table like this, right? So I have these feature, that is room, area, and this is your garage, right? And this is price. Okay. If number of room are 2, area is 2000 square feet. Oh, it's a very small room. We can make it 4, right? And then we have a 1 garage and price is 5. Okay. So you have these kind of values, right? Can anybody tell me what is a target in this? Can you set the target and tell me which can be the target if I want to predict, and what are the X features? If I give you this data set, how would you decide?
Price.
Price is a target.
And we call it, what else we call it?
Oh,
Why?
why?
We denote it with the Y, but there is another word which we did in the poll.
Dependent.
Yes, right. Dependent variable, right? And what are
Yeah.
those features?
X.
Yes. And what else we call it?
Independent.
Yes, right? So what is the definition of this now? What is an independent feature? So these values are interfering in the price of this, right? So this means these are your independent variable, right? These values you are using to predict the price of the house. If I'm making any changes in this, I make an area 3000 square feet, the price will automatically increase, right? So these features are known as independent variable. And this is your dependent.
Now we can still we can still say that
Mhm.
even the price is the Y variable, right? We can still have other columns can be dependent variables as well, right? So I
Yes.
can use the price and the square foot to predict the number of rooms it has, right? That's still fair, right?
Yes, it depends upon your goal. Yes, you are right.
For sure.
Because
for sure,
setting a goal and target, it depends upon over requirement,
for
right?
sure.
Yeah.
Yeah.
Yes, you can. Okay, so we will move ahead. Now look at this example. This is a regression one, right? So this is your table. Here I'm saying if number of bedrooms are 2, the selling price is this much. If number of bedrooms are 3, this is the selling price, right? So in this has become your X or independent feature because it is helping us to predict the selling price of the house, right? If I make any changes in these, if I'm making, see, if I'm increasing the number of rooms, the price is affecting, right? So this means this is the independent features, this is dependent feature. Your price is dependent on number of bedrooms. Rest is depend upon the goal, right? Whatever your goal is. If you look at the right side, this graph, on x-axis, you have a x feature, and this is your price on the y-axis. Because when you draw the graph, you on the y-axis, we always have a target. And on the x-axis, we always have a features. Okay. If the number of the features in this, what is the number of feature? Bedroom here of the x, right? So if the number of bedrooms are increasing, the price is going up as well. Okay. So you can start the price from here 120, right? And then 3 lakh, 4, it can be 5, right? Because here the room number is 2, 3, 5, 6, right? So it is increasing in the same direction. Okay. So this y variable is dependent, your target variable is dependent on x feature. Okay. So this is the difference between independent and dependent feature. Okay. If you did not understand, I would repeat after class as well, because this is the most important thing. Okay. If you did not understand clearly what is independent dependent feature, this is not like good for you to move ahead like this way. Okay. You will get a more chance to look into this when we will do the again code along. So in regression, what example can you think of? Can anybody tell me? One example we already did. House sale price. Any other example?
Does it always have to be like a positive change, like increasing, I guess?
Yes, it depends. Sometimes it's in negative way as well, negative correlation as well. But your target should be in real number and continuous.
Okay.
So an example of that might be we might have an X feature of miles away from the beach. And so as the further we get away from the beach, the higher that number comes, then probably the price of the house is not going to be as high.
Okay.
So we'll have a reverse or a negative correlation.
Okay. Thank you.
So can you think about
And-
any example? Yes, yes.
I guess I had a question about supervised learning regression, and I guess I'm just wondering, how is this any different from, linear regression in any other sense? Like, if just any multivariate linear regression, how is this any different from that? Like, why would I want to do this as opposed to
is
just
an example.
doing a linear regression model in just in any other side?
That is a good example of a regression learning model. But we're going to teach you a bunch more that are more powerful.
Okay.
Any example? House sale price example is there. Any other example? Anyone can think?
Maybe the weather and the month, or the temperature in the month, like in certain city.
Okay. That is. Yeah.
Oh, I was gonna say like how much time you spend with your pets and your mental health. So that's probably one.
Yeah. Stock
Very good.
market from Navnur. Yeah, absolutely. That's how I got started.
Good. Okay. So like home sale prices, total sales, right? How many number of advertisement and how many sales are done? stock predictions, if you want to predict the age or height, maybe based on the given features of the person, right? So this is also the regression problem. You can think more, okay, out of this. So how many other examples can be type of a regression? Okay. So now we will move ahead for the classification. Classification means, like in regression, you have seen when your target variable is continuous number or any real number, that is your regression. But in classification, your target variable is always a type of class. Okay. So this is a major difference, very important. You should know the difference. Look at this. So this is my one table. Here, I'm writing age, sugar level, right? And BP, and one other feature, I will name it X, okay? And this is your target. The patient have a disease or not, okay? So if you are writing some values here, I would say it's a 0, okay? Or if I'm writing some values, I would say 1, right? So you can see here, I have a, is this continuous number, or if I repeat it like this way?
It's binary.
Yes, right? So you have a two classes here, 0 and 1, right? So when you have a target with the two classes or more than 2, this is always your classification problem. If I'm saying predict whether the patient have this disease or not, I'm asking whether the patient have disease or not. So I am classifying two classes only, yes or no, true or false. False, positive, negative, right? So always there are two things. I'm talking about the classes. I'm not talking about any real number, right? It is not in the continuous form. So this is called classification. This is a major difference between regression and classification. Okay, we will look at the example again here. Look at this. So here, this is the one table in which this is the email messages, and we are predicting, is it spam or not spam, right? There is a no number. We are just writing this. But instead of this, it can be in a binary form. Okay, this is 0, this is 1. Okay, so it can be binary. Don't be confused in the binary numbers. Sometimes it is not there. Okay, it's in the binary form. So this is a classification problem. Okay, this is not resulting in the continuous or any real number. 0 and 1 is a binary. This is a type of class. This is not real number or not in continuous form. Okay, so this is the major difference between classification and your regression. When you want to predict something, whether it will happen or not, whether this is true or not, whether it is positive or negative, whether it is a 0 or 1, right? But in regression, like a price of the house predict, age or height prediction, stock market prediction, right? And other any example, if we take any other example, your advertisement, right? So these are resulting in the continuous, right? We're not talking about any specific thing. So this is a major difference between classification and regression. Okay. Anybody have any confusion? To understand the difference between classification and regression, please feel free to ask. This is very important. Take your time. If you something come up in your mind, please feel free to ask. So now we will talk about the examples of classification. As I have already given this example, positive or negative for a disease. Like we have a patient's records. We want to know based on those features whether the patient have a disease or not. If his BP level, his sugar level is this, the patient have a heart sugar or not, right? Dog or cat. If we are talking, if you are giving the images of mixture of dog or cat, your machine is going to classify, is this picture of a dog or cat? Again, there are two classes, no continuous number, right? Low price, medium price, high price. This is an example of multi-classification. More than your two classes, you can say, or one classes, but there are multiple classes, right? Low price, medium price, high price based on given of the X features, right? What the species of the tree, right? This is again, it can be 3 type of species, it can be 2 type, it can be 4 type, right? It depends. So this is again classification problem. Okay. So you need to take care when you got the data set, you need to think a lot. Is this regression problem or classification? Okay. Okay, this is a just knowledge check. Pradeep, whether the patient have a disease or not, is this classification or regression? Anybody?
Classification.
Great. Right. It's a classification. Okay, this is just a summary of the key differences between classification and regression. So regression is work based on the target, which have a continuous value, any real number, right? But classification based when the target is your in the form of classes, or maybe binary, maybe positive or negative, spam or not spam, false or true and false, right? Regression algorithm used for continuous data, right? For the numbers, when your target is numbers. But classification used for discrete data. Okay. Regression algorithm can further be divided into your linear, non-linear, but your classification can be divided into binary and multi-classification. Okay. So this is the key differences between your classification and regression. Okay. Anybody
So,
have? Mm-hmm.
I have a question. So are you saying that depending on what, we're trying to study or look for, the data, we will choose obviously either, well, there's probably more, but regression or classification. So when we think about what we're predicting, if we know that it's going to be like a true or false, a positive, negative, we'll go with classification. And then if it's otherwise, we have regression or possibly others to choose from, correct?
Yes.
Okay.
Right. Even like you are doing the core assignment, you are under the classification topic, right? You know it's a classification core assignment, right?
Yes.
But my recommendation is, just give me 1 second. So like my recommendation is when you are doing the regression and classification exercises, read the goal carefully. Look at the data set carefully. Even then, already it's a classification. Okay. Yes, please.
Well, I was just gonna say, so what do you call it when it's both? I mean, is it possible to have a classification like yes, like this is the thing and this is to what degree that is, or no, but we can tell that it's this short from being yes? Like how does that figure into models? Like what do you call that? Is that a regression or a classification combination?
Like if you are saying what I understand from your example, if you have a data set like
It's like you say, yes, there is something, it is correct that this thing is like this, and
Yes.
here's the percentage degree to which it is set up, or no, but if it moves towards this degree, it'll be further along. Do you understand what I'm saying?
yes, if you are talking about the pattern like the percentage of the degree, then if the percentage of this degree, then this is answer like this way.
Yeah.
Yes, this is classification.
Okay. But so basically it's a classification even though it uses numbers and points.
Yes, yes.
Okay. All right.
Because as either it's a regression problem or it's a classification, your X features can be a number of anything.
Okay. So it does. So I see what you're saying. Yeah. Okay. Cool.
Okay. Now till so far you have learned about the very important terms. What is machine learning, application of machine learning, type of machine learning. We talked about the regression, classification, right? And now we are going to talk about the most another important term, that is your train and test split. Okay. Why we split the data into train, test, and test split. Okay. This is very important terms. Why you need it? Okay. You need to understand the terms as well. Okay. So now we will move ahead. Now look at this table. Okay. So as in the previous slide, you have learned about the X feature, right? What is X feature and what is Y feature? So Y is your target or dependent variable which you want to predict. It can be your classification problem. It can be your regression, depend upon your business problem. And what is X features, which is going to be help you to learn the pattern, right? And then it will show you the answer, right? Your target variable is dependent on these feature. It is going to be learned from this kind of pattern. If this is the value, this is the answer, right? If these are the value, this is the answer. Okay. So this is the difference between your features and target. This is just the repetitive because I have already explained this in previous slide as well. Okay. So now if we move ahead, look at this example. Again, this is a house sale price example. In this is your target feature, the sale price, the blue box, right? And this is your X features, which is going to be interfere with the value which you want to predict. That is called independent features as well. Okay. Now, if you have this data set, why you need to split it? Why you can't use it together? What is the reason behind that? Why we always split the data before fitting into the model? Why you need it? Okay. So this is your complete data set, which I have shown you in previous slide. House sale price, X features, and your target feature. That was your complete data set. But when you applied here some Python method, that is train, test, split, I will show you in the code along again that after using that method, your data set will be divided into two parts, training and testing. Okay. So train part we use to train our model. Okay. Your model will learn from the train data. Okay. But the test data we use to evaluate the model. Okay. So what it do? It simulates the making the prediction when the answer is truly not known yet. Okay. So this is we use to evaluate. If you memorize the life cycle of the machine learning, after model is trained, we have seen there is a model testing, right? That model testing is done by your test data. Okay. This data set is always hidden from your this data. Your this data does not know anything about it. Okay. So that's why, and we use it for model validation. That's why you need to split the data set. Okay. We want to hide the data, which part of the data we want to use to evaluate the model. If I will not split it, my model already trained with the all data. So my model already knows all answers, right? So how I will make sure it will work good at that time, but it is going to be fail with the new data. Okay. So this you will learn, like you will come to know more in the next lesson as well, and in upcoming classes as well. It will be going to be more clear to you slowly. Okay. But this test data we use to evaluate the model. We always hide this data from training. Okay. So this is very important. Anybody have any question about the train test split? Why we need to split the data set? Anybody? Okay, take your time. Okay. If something come up in your mind, please feel free to ask. So that was, we are looking at that. This is a clear another example. So you will get a more idea. This is your full data set with target and full data set, right? And then if you look at these are your X features, pattern data, and this is your target. When you split it, it will look like this way. Okay. So in this train data, it will be divided into X train, Y train, X test, Y test. Okay. So it is going to be used to train the model. Here your model know the answer. Your model know if these are the value, this is the answer. Okay. But in this case, you are going to predict, when you are going to predict on X test, your model does not know this answer. Okay. Your model is going to be predict based on this pattern only, because your model already learned from this portion. Okay. So your model, when you predict the value of the X test, whatever answer it will give, you will compare this answer with this one. This is how we do model evaluation. Okay. Does it make sense? Okay. So in the testing part, your model does not know the answer. It only have a data, this pattern X features. So whatever you predict, it is going to be compared with this one. So if it is matching 95% or maybe 80, maybe 60, this means your model is working this way. This is very important concept. Okay. If anybody have any question, please feel free to ask. Take your time. Okay.
So usually you split the data in half or for training and testing?
Yes, by default, it's a ratio of your 75-25%. Okay.
Okay.
If you don't mention any ratio, if you want, you can. Okay.
Okay.
What is a trained data set? Good. Two more responses are left. Okay, great contribution. The answer to this question is first. Sorry, the trained data set is used to train the model. Okay, we don't use the trained data set to evaluate the model. Evaluation means testing. So for testing, we use only test data. Okay. Now we will move ahead, machine learning library. So this is the very powerful tool, one-stop solution for your all problems of machine learning. This is sklearn. Okay. So in this is used scikit-learn. This works great with your Panda and NumPy. It's a very large library. You don't need to import everything. Whatever is required according to your core assignment, that libraries only you need to import. Okay, don't add the extra code which is not required. Remove that. Only how you can import. If you look at these, import pandas as PD. Whenever you see this keyword import, what does it mean? Anybody? If I am writing import pandas as PD, what does it mean?
We're importing the
Java.
library.
Yes, and PD is a
That's how we're gonna be referring to it in the code.
yes.
Alias.
Yes, it's an instance of that. When you look at the from sklearn.dataset import load IDs. So from means why I did not use import here?
Well, we're
Because-
importing sorry, go ahead, sorry.
Yeah.
Oh, because you wanted a specific part of the library, not the whole thing. So this Sky sklearn, it's in the load iris.
Yes, but it's
Sorry,
not a.
sorry,
Mhm.
sorry. Load iris is in the sklearn dot datasets.
Yes, right?
Other way.
So this is your library, okay? But whenever you see the from, this is your package. This is correct. This is a part of this one. I don't want to use the whole package. I want to use some one library out of this package. So I will do like this way. From sklearn datasets import load IDs. Okay. Import, whenever you see import in start of word, this is library. Whenever you see from, this is package. Okay. So this is the difference. Now we will move ahead. This is just the temperature check. It will help me to know how much all you understood today from the lesson. Did you all see the poll? Great. Understood the difference between regression and classification. Three more responses are left. Good, good. Good. Thank you. So if anybody have any question, they can stay. We will talk and discuss again. This is a time of code along. Here, we will first import the libraries which is required. Only try to make your code as much as simple you can, well organized. Use the text boxes, markdowns, code, comments properly. Okay, because even if you open your notebook after 6 months, 3 months, you should be able to understand what you did. Okay, so it is first you import pandas library, which we use to for data frames. And then we are importing the package data sets to load the dataset load iris. And then sklearn model selection, train, test, split. This is the method which we are going to use to split your data set. Can anybody tell me why we need to split the data set?
Well, you need the training data and then you need the testing data. So you need to split off the training data from the testing data so that you won't have any data leakage. And you can use the training data to train the model, and then you can test it to do the model validation with that.
Yes, great answer, yo, great. And this is your, then you will load the data set, right? Using this method, iris. So this is your data in this array. And here your target name is this, right? This is a type of species. Is this classification problem or regression problem?
Classification.
Yes. Good answer. And then we will convert this array into data frame. Okay. Here you will use your scales which you have learned in stack 1. You will convert it into data frame, right? Set the target and it will look like this way. Okay. So in these sepal length, sepal width, petal length, petal width. These are your X features. This is your target, right? It is coming in the binary form. It can be multi-class, right? Because there are 3 types of species, 0, 1, 2. Okay. This is very good practice whenever you got the data set. Sorry, never ever use your original data set for pre-processing or model fitting. Always make a copy. Okay, it will help you to, because if you make a changes in your original data set and you want to revert something, this is a very big task again. Okay, and we don't want any data leakage further. Maybe you are using the same data frame for visualization and you are trying to fill the missing value, right? Same data frame you are going to use for model fitting, that will also cause data leakage. How? You will learn in the upcoming lesson. Okay, so now we will make a copy. Okay, this is my original data set and this is my copied. So I am going to use this one. I will keep safe this one. Okay, and now if you look at this info, so what you can see in this info, can anybody interpret it? Anybody? What this info method gives you the information?
Well, you have 5 columns. They're all numerical.
Yes,
There's no object.
yes. And there is a, we can also, you can look at the like information, there is no missing value, right? So this
Right.
is give you the brief introduction about the data set. So if I ask anybody can answer, these kind of steps you will connect at which step with the machine learning life cycle? At which stage you are right now, according to machine learning life cycle? Anybody?
The one before wrangling.
What is the name of that one? We are exploring. Yes. We are exploring the data set. And then you will check the missing value. Okay. This is mandatory. In your each and every core assignment, you need to do this step. Even it is not written on the LP, this is mandatory step. This is by default step. Never ever miss this step. Okay. So whenever you are doing this, although I know we can also look at here, but don't miss this step. This is important. Okay. It will help you how sometime maybe you have something missing in target. Okay. So even you should know the count of the, like how many values are missing, right? In interview, maybe they will ask you, did you find the missing value? So which like this feature was there. So did you see how many missing value was there? Right? So this is important, very important to check the missing value. Okay. And then check the duplicates. This is also important. Don't miss these steps. Okay. Duplicates, we don't need the duplicates. If there is any duplicate, just drop that. There is no use of duplicate data. Okay. And then now it's a time to split the data set. Okay. Here, because I don't have anything missing here, there was only one thing duplicate, which I dropped, right? My each type of feature is coming in numbers. I don't need to do anything with it, right? Now we will do one thing, we will split it into X and Y. Okay. So what are X features? Which we use to predict the value, right? So this is your, in X feature, I will drop the target and my X features will be set. Okay. And I will set the target iris type. You can see this is a markdown is added here. So you need to follow these things. Proper markdowns, comments. Okay, this is very important. And then validation, train, and test split. To split your data set, we use train, test, split. This is the inbuilt method. Okay. And it will automatically split your data set into 75 or 25 ratio. You don't need to worry about that. Okay. So you need to declare X train, X test, Y train, Y test. Okay. And then train test split X and Y. Random state is equals to 42. This is another important feature, sorry, parameter. Here, if you set this parameter, whenever you will doing the predictions and you refresh your notebook or fitting the model again by making some changes, it will show you the result same. Otherwise, it will show you the random result. Every time different output if you are not setting this feature. And random state is equals to 42 is not mandatory. You can use any number. Okay. But this is the most widely used number, which is like you will find in sklearn library as well. Okay. So that's why we use. So this is the way how we split the data set in code using Python. Okay. The purpose behind that, because we want to use our test data to evaluate our model for model validation. Okay. So this was all about your today's code along. Okay. If anybody have any question till so far from the concept, any confusion, please ask. Before I open a challenge notebook for all of you, anybody have any question? Okay. So this is a summary what we have you have learned today. What is machine learning? Different type of machine learning, train test split, why you do it. Okay. And this is your challenge notebook. So here we have a wine data set. Okay. I have already imported these libraries. Okay. In these, load the data set, separate the features. Your challenge is check for duplicates and missing data. Deal with them if it's necessary. Okay. Split the data.
I have a question.
Mm-hmm.
When you do the initial data load, why does it look like that when you do the initial load before you transform the data into a data frame? What is that original, like, yeah, why does it look like that?
This is in form of array.
It's an array, but even the stuff after the original array, it's like you see the arrays like the 0 and the 1s in the brackets, but then there's a lot of that other stuff underneath that. Like, what is all of that?
This is like in form of list and arrays. This one. This is
Down,
array.
down below this, Nirja.
Which one?
So what you're actually seeing is a dictionary, it appears.
Right. So all of that, exactly. This is all a dictionary.
So this is the description. That's part of the description that they provide in that particular key value pair.
This is dictionary. This is a combination of many things. Here you have an array. Inside this is list. And this is dictionary. This one. Like they are giving you the text of what does it mean. And this is the value. What does it mean? This is a description of the data set.
Yeah, so X, Y, description, and then feature name list.
Yeah, this is
Are
summary statistics.
the four keys.
Does it make sense?
Yeah, it does. I guess now I can read it. So all of this stuff eventually, it all makes it into the data frame. It's just all kind of laid out here in a very bizarre way, but it makes sense.
So we're actually we're going to add the data. So if we come up and look at the first key,
This one.
That's the data, and so that's going to be your X, your independent features.
And
Your
this is your
target is going to
target.
be your Y, and that's going to be your dependent feature, excuse me. And then we have frame, none. We have target names.
Target names.
Tells you what those are. And then we have one key that is description. That just
Mhm.
talks all about everything about the whole data set. And then last one is feature names. So the description doesn't make it into the data frame. We're going to use the X, the Y, and the feature names. Does that help?
Yeah.
Is that kind
does,
of like the
thanks.
README file on?
Kind of. It has some equivalent purpose to it, I would say. That particular, the description key. Yes. You'll have a chance to read through it later when you open the notebook.
Yeah, because they are giving every information, each and every about the target, summary statistics, everything. What does it mean? With just their key name in the form of array and the list, you only need to convert it into the data frame which is required. So you can fetch out that key name only and just set into the data frame. That's it. Does it make sense?
Yep, thanks.
Okay. So in this challenge, all of you need to check for duplicates, missing data. If it is required, you need to deal with them. Then you will split the data into X and Y. Okay. And wine type is your target column in this. Okay. You also need to tell, is this a classification problem or regression? Okay. And then second challenge is perform a validation split. Use 30% of the data for your test data. How you can do that? You may need to look for documentation. Okay. By default, I already told you it's a 75 and 25%. But if you want, you can set the parameter. Okay. Here you need to set the parameter for test set size. Okay. So I'm going to stop sharing and